This is the extrusion die of a pipe, and the section of the pipe is like this. It has a notch over here like this. This is the extrusion die. So this extrusion die is made up of mandrel, the die ring, and the bolster plate. So this first of all, what happens is the billet is pushed from the mandrel to the die, and the see, this is the mandrel, and it has a protruded portion or boss from where the billet can be pressed. If suppose this was not present, then while pressing, what would have happened is the metal may flow outwards, and the extrusion could not be properly, could not be done properly. As we can see over here as well, whenever if suppose this was not here, then while pressing the billet, the material may move outwards and it will not enter into the cavity, and hence the extrusion process would have been failed. Now let's get deeper into the design. This is the mantle and this is the die. The mantle, the material will flow over here and it will enter over here like this through the tapered portion. Why we have provided this draft is to minimize the friction force and back pressure, and we need to provide less force for extrusion if the drafts are present. And this is the cavity. Now we will see into the we will discuss this gap, why this gap is provided over here. You can see that this is the gap and this is the gap of 3 mm. Here also we can see why this gap is provided, why we are focusing on this. We will discuss this later. So let's jump into this design. I will hide this pipe. See, now we can see this orange color is the die and this red color is the mantle. So the combined assembly of this die and mantle will create this section. You can see over here. This is the section. Now let's see one more thing. You can see this is the leg of this mantle. Let's see from here. See, this mantle is connected by these two legs. So if suppose this billet is pressed, then these two legs want to be filled directly. So we need to provide some provision so that the legs can be filled and proper section can be obtained. So that is the reason the gap is provided, which I was discussing over here. Now let's look into the mantle, how we provide the gap. See, these two are the legs, and you can see clearly that this leg is a distance away from this surface. So if suppose this leg would have been merged to this surface, then there would not have been filled properly. There would have been no chance that the leg could have been filled. So if because of this gap, what will happen is water will flow come from here and it will fill this gap here, and this section, the die will be having this section on this profile on it, and the material will flow ahead and the section will be completed. So let's see over here. I will hide. We will see in the exploded view. This is the exploded view. See, this is the portion over here, and this portion will be merging over here, and you can see this is the gap. The water will flow over here, and whenever, see, this is the die, this is coming exactly at that portion. So the water will flow from here and here and fill the leg and will come outwards, and hence this is the reason we are providing the gap in that leg portion, so that the water can flow over here and here, and it will fill the complete section in the part can be extruded easily. So what is most important thing in extrusion die is to make a proper cavity and to ensure that the complete cavity is filled by the material. And see, this in this what happened was, due to those legs the section was not filling completely, so we provided some gaps on this mandrel so that the legs can be filled, and and whatever the final result would be, that the section would be obtained. So this is the extrusion die for